Yeah, in the previous sessions, we were discussing different concepts of our friction topics. So in this session, we are going to start with the solved examples. So la kwanza, a block of mass 270 kg is pulled along horizontal surface. If the coefficient of kinetic friction between the block and the surface is 0.4, what is the force acting on the block as it slides? A block of mass 270 kg is pulled along horizontal surface. If the coefficient of kinetic friction between the block and the surface is 0.4, what is the force acting on the block as it slides? So in this case, you are not given the acceleration of the block. As I told you that, for example, in case of horizontal table, ambayo tunakuwa tuna table kama hii hapa. This is our horizontal table, and then from this horizontal table tukawa tuna block wetu uko pale. So block ana mass mg, normal reaction is R. This is our block. So tunaipull we block with a certain force F, and then huku nyuma itakuwa inavutwa with the frictional force Fk. Sasa kama hujapewa acceleration kama kwenye hili swali, manake you assume acceleration is equal to 0. A body is moving with constant velocity. If the body is moving with constant velocity, utakachokisema hapo nini? Utasema kwamba huwa tunasema net force ni sawa na F minus kinetic friction Fk, but Fk ni sawa na mu k R, and in this case R is equal to mg. So itakuwa ni Fk ni sawa na mu k mg. Toka hapo tukija kuingiza hapa itakuwa net force ni sawa na F minus mu k mg. You can call this as equation 1. Also we are saying net force is sawa na mass times acceleration, but in our case acceleration is equal to 0 meter per second square. Body is moving with constant velocity. So kama na move with constant velocity, that means net force will be equal to 0. Kutaweka 0 is equal to F minus mu k mg. F atakuwa sana mu k mg. So force inayoact hapa itakuwa ni mu k 0.4, mass ni 270 mara 10. Kwa force itakuwa sana 1080. Kuzidisha hapo 4 mara, sababu hii 0.4 mara hiyo 10. I mean hii 0.4 mara hiyo ni 4 mara hiyo 270. Tapata jibu kama hilo. So that will be the force acting on the block as it slides. And for our case, final answer ni hapo 180. So we can move to the second question. A box of mass 2 kg. A box of mass 2 kg rests on a horizontal surface. A force of 4.4 is required to just start the box moving. 4.4. So we are given mass is equal to 2 kg. Then your force ambayo inakuwa required ni 4.4 is required just to start the box moving. What is the coefficient of static friction between the block and the surface? Coefficient of static friction. So again, in this phenomena, we can draw the diagram in which you have the block in the horizontal surface. The block in the horizontal surface, and then from there here we'll have mg Then here we'll have normal reaction R. Mg, force is pulling to this direction. F, static friction force to this direction. F, static. So what will happen here is that for the block to start moving, then tunasema F must be greater than or equal to Fs. So F will be equal to Fs, which is equal to mu s R. But in this case, R is equal to mg. So F will be equal to mu static mg. F hapo atakuwa sana mu static ambayo ni tunatakiwa tafute mu static coefficient. Mu static sana force F divided by mg. So we are given force F is equal to 4.4 divided by mg, which is 2 times 10. So it is 4.4 divided by 20. So dividing that, mu static itakuwa sana 4.4 divided by 20, it is 0.22. 0.22 will be our coefficient of static friction. So that will be the solution for our solved example number 2. As you can see, the answer for the question is this one. Moving to question number 3. Question number 3 ambayo tunasema kwamba aluminium block of mass 2.1 kg rests on a steel platform. Kwa tumepewa mass of aluminium block na tumeambiwa imerest kwenye steel platform. So that means tutakuwa tuna steel platform like this way, and then tutakuwa tuna aluminium block. This steel platform is simply horizontal one, so tutakuwa na aluminium block like this way. Then here we'll be having the force pulling it downward mg and the force pulling it upward R. So mg downward, normal reaction R upward. From there tutakuwa na force inaenda hivi F, na force inaenda hivi ni Fs. So wanasemaje hapa? Wanasema kwamba tumepewa mass pamoja na horizontal force hapo is applied to the block. Given that coefficient of limiting friction is 0.61, will the block move? So manake tumepewa mu limiting ni sawa na 0.61, and the mass of block we know ni 2.1 kg. Mass of block we know, but also we know about the force ambayo ni sana 15 Newton. Force sana 15 Newton. So from there tutaangalia kwamba huyu force atakayekuwa applied ata exceed huyu hapa. So let's calculate about the limiting friction. So limiting friction Fr will be given by mu R, then normal reaction R. But in our case, normal reaction R is equal to mg. So Fr will be equal to mu R, then mg. That is to say 0.61 times mass 2.1 times 10. So final answer ambayo unaweza kupata hapo 0.61 times 2.1 times 10 is 0.61 times 2.1 times 10. So you get it is 12.81 Newton. That is the limiting friction force. Remember, the limiting friction is the force which tend to prevent maximum static friction force, which tend to prevent the motion of this block. Now, in case the applied force exceeds this, that means the block will move. So tutasema hivi, since the applied force exceeds the limiting friction, the block will move. Now if the block will move, what will be its acceleration? Now in this case, the story changes from static to kinetic, and then the block will be moving to this direction with the acceleration A. So remember, I told you that net force will be equal to applied force F minus kinetic friction Fk. But in our question, we are not given the coefficient of kinetic friction. Remember, we had a table of coefficients of kinetic friction. So we'll be using the coefficients on a table to solve this question. So therefore, from the table, mu k is equal to 0.47. Unaweza kaenda tu kuipitia hiyo ukaiona mu k kati ya aluminium na steel, kwa sababu tusema block of mass hapo amerest kwenye steel platform. Hiyo ni coefficient kati ya aluminium na steel. Kwa hiyo tunataka kupata net force. Fk kwanza itakuwa sana mu k, then normal reaction R, which is mu k, then mg. So itakuwa sana 0.47 times 2.1 times 10. Multiplying this, we'll get 9.87 Newton. Sasa from there ni kwamba net force itakuwa sana applied force ambayo ni 15 Newton minus 9.87 Newton. So net force itakuwa sana applied force ni 15 minus 9.87. So we'll get the final answer, which is 5.13 Newton. 5.13 Newton. Sasa tukiwa tumeshapata hiyo net force, tunakuja tunasema kwamba from Newton's second law, F is equal to mass times acceleration. So mass times acceleration itakuwa sana, our answer 5.13. Acceleration will be 5.13 divided by mass, which is 2.1. So acceleration itakuwa sana, ukichukua 2.1, ukichukua answer ganya kwa 2.1, you get it is 2.44 meter per second square. That will be the acceleration of the block when it starts moving. Kwa hiyo you will see the solution for this question in the notes, and then the final answer for the acceleration of the block when it starts moving itakuwa ni hiyo hapo, Kwenye kipindi kijacho tutaendelea na solved examples mbalimbali kwenye hii topic ya friction. Thank you.